Hello, Math 142. Let's look at our activity one. Of course, you may have a slightly different numbers that I do in this copy right here. So we have Clyde wanting to swim on a straight line towards the boat. There is a spotlight right here that makes light in a circular manner. The distance between the spotlight and the boat is 111 feet. What else do we know? We know that the radius of illumination is 87. So from spotlight all the way to this green uh, circular curve, we have 87 feet. Clyde himself is 43 feet from the spotlight. Two parts to this question. Part A is asking how long in seconds will it take Clyde to reach the boat if he swims along the straight line. Round to three decimals, pay attention to units. And part B, how long in seconds will it take Clyde to reach the partial illumination? So from here to here, and of course, I have to find out the distance between here to here and solve for the time. Okay, so here's my PDF file. Uh, so for part A, the first thing that I need to do, I need to convert the speed of Clyde swimming into feet per second from mile per hour. We know in 1 hour there's 3,600 seconds and 5,280 feet in 1 mile. Converting to feet per second, I got 2.347, um, rounding to three decimals. So that's a Clyde swimming speed, 2.347 feet per second. Now, here I want to find out Clyde is here and the boat is here. Okay, what's the distance between Clyde and the boat? Okay, um, I do have a right triangle, 43 feet here, 111 feet here. So the distance, the hypotenuse is square root of 111 squared plus 43 squared to three decimals. I got 119.038. And what is it that we know? We know time uh, equals distance divided by rate or speed. So in this case, 119.038 divided by 2.347, and that gives me a 50.719 seconds. So it takes Clyde 50.719 seconds to swim from where he is all the way to the boat. Now for part B, I need to find out the distance between Clyde and this illumination part. Okay, and well, two things I know. I can find it since this one right here. I do have. If you think of this horizontal line as your x, and this vertical line as your y, you can see that this point right here where the boat is 0, comma 111, and this point right here is going to be 87, comma 0. So I know for the circular spotlight, I can have an equation of x squared plus y squared equals 87 squared, which is the equation of a circle. Now, the straight line that he is swimming, y equals mx plus b, has the form of my y-intercept is 111. The slope is negative 111 over 43. Okay, so you could think of this as minus 111 over 43x plus 111, but I left it in this format. I thought that would be easier to work with. So what I used is y equals mx plus b right here. So now I have one equation here. Okay, I can, now that I know what y is, I can substitute this y, this 111 minus 111 over 43x for the y in here. So now I get x squared plus 111 minus 111 over 43 quantity squared equals 87 squared. And if I expand that, I get x squared plus 12,321 minus 24,642 over 43x equals 87 squared is 7,569. Rearranging this, just subtracting 7,569 from both sides, and I'm using the decimal. If you divide 24,642 divided by 43 to 3 decimals, you get 573.070. And so now I have a quadratic. Using quadratic formula, I get x equals to 564.654. I'm going to toss that. I don't need that one. That's way too far. The other solution is x equals 8.416 that I'm going to be using. It makes sense. So it makes sense that if you just look at down below this point of intersection right here, it makes sense for this part to be 8 point something. Okay, now when x is 8.416, I know that y equals 111 minus 111 over 43 times 8.416. So the y value for x is 89.275, simplified to 3 decimals. Okay, now I need to find the distance between the 2 points. That one point right here is the intersection of Clyde's path and the illumination part caused by the spotlight. So the x value of 8.416, comma, y value of 89.275, and the position of Clyde is 43, comma, 0. Using distance formula, I get d equals x minus x1, so 43 minus 8.416 quantity squared plus y minus y1, 0 minus 89.275 quantity squared, take square root of that. D, or distance, is almost 95.74. Okay. And what's the time? Time is distance divided by rate or speed. So 95.74 divided by the speed of Clyde swimming gives me approximately 40.793 seconds. Okay, well, I hope you find this explanation helpful, and I'll talk to you soon. Thanks, bye-bye.